Hey Tutorinos, it's Tutor Pat with a quick hit here on how to complete the square. What is completing the square? It's a technique we use to rearrange the standard form of the quadratic into the vertex form, which will enable us to see the minimum and maximum points of the parabola. I can also use completing the square to find the roots or zeros or solutions of a quadratic. I can also use completing the square outside the context of functions. I can use completing the square technique to take a non-standard circle equation, meaning a circle equation that's not in the standard circle equation format of quantity x minus h squared plus quantity y minus k squared equals r squared. I can use completing the square twice to get my unruly circle equation into something more recognizable. So, in short, I can use completing the square for a lot of stuff. I'm going to first talk about in the context of the quadratic because that's how often you're going to see it. Just as a reminder, the quadratic is a function that is often written in standard form. ax squared plus bx plus c, usually set equals 0, where a is my first coefficient, b my second, c is my third. I'm going to give a specific example here. We're going to use x squared plus 7x plus 10 equals 0. So that means my a coefficient here is 1, my b coefficient is 7, and my c coefficient is 10. So here are the steps to complete the square. Number 1, I have to make sure the a coefficient is equal to 1. So a coefficient green, that's equal to 1, we're good to go. Completing the square does not work if the a coefficient is not positive 1. Second step, we're going to move the c coefficient to the other side of the equal sign. So in this example, the c coefficient is yellow. So I'll rewrite this as x squared plus 7x space equals negative 10 space. And you'll see why I'm putting those placeholders in. Third step is we take the b coefficient, we multiply it by 1/2, and then square it. So in this context, my b is blue. It's also 7. 7 multiplied by 1/2 is 3.5. So 7 times 1/2 is 3.5. And then 3.5 squared is 12.25. My fourth step is I'm going to add that number, and by that number I mean this 12.25, to both sides of the equation. So now you see why I add those spaces, because I'm going to add, make it gray so you can see why. I'm adding 12.25 here and 12.25 there. I'm keeping the equation balanced. So if I wanted to rewrite everything in a way that's easy to see, it would be quantity x squared plus 7x plus 12.25 equals, and I can simplify that, negative 10 plus 12.25 would equal positive 2.25. Now, my fifth step is I'm going to rewrite the left side of the equation as a perfect square. perfect square is a binomial that's multiplied by itself. And if we look very carefully here, we see that that can also be written as the quantity x plus 3.5 times the quantity x plus 3.5. Because 3.5 plus 3.5 adds to 7, but multiplies to 12.25. So I can rewrite the left hand as x plus 3.5 squared equals 2.25. Now we've completed the square, and we've come to a thrilling point, because I can do two very different things with this, depending on what I want to do. So let's copy this, break out a new page, and I'll tell you what I mean. I can go in two directions. I can solve it, meaning find the zeros or the x-intercepts. That's one thing I could do. Or I could get into vertex form and find the minimum or maximum of the particular parabola that this quadratic graphs to. I'll show you how to do both. So we'll start with solving. So solving, relatively straightforward. So if I have x plus 3.5 squared equals 2.25, what I can do is I can take the square root of both sides. Now when I take the square root of a quantity, meaning something in parentheses, I don't have to worry about positive or negatives. That just becomes x plus 3.5. And then 2.25, the square root of that, is going to be plus or minus 1.5. So I can rewrite this two ways. I can write it as x plus 3.5 equals positive 1.5, or I can write it as quantity x plus 3.5 equals negative 1.5. Now, if I finish this up, and I subtract if I subtract 3.5 from both sides, I'm going to get negative 2. If I do it on this side and I subtract 3.5, I'm going to get negative 5. And indeed, the two roots of this parabola are negative 2, negative 5. So if I wanted to solve this, and I didn't want to factor the c coefficient or use the quadratic formula or graph it, I could complete the square and it'll get the job done just fine. But that's not all completing the square will let me do. I can also get it into vertex form. Now, as a reminder, vertex form is a derivation of the standard form that allows me to see at a glance what the maximum or minimum point of my quadratic is. So, and that's going to be a times the quantity x minus h squared plus k, where hk is the vertex, meaning either the top of the parabola if a is negative, or the bottom of the parabola if a is positive, meaning the maximum or the minimum, respectively. So this is really easy. So here I have my parent equation up here. Bring it down here. And all I need to do to get into vertex form is just bring this over here. So I'll rewrite it as x plus 3.5 squared minus 2.25 equals 0. And I instantly know where my maximum or minimum point is. So this is my h value, and this is my k value. Now notice the signs flip there, so that must mean my h value is negative 3.5. And I notice a negative sign there, so that must mean my k value is negative 2.25. And if you have a calculator handy and you want to graph quantity x squared plus 7x plus 10, you'll find that the minimum value, because that's a positive quadratic, it goes up, is at negative 3.5, negative 2.25. So we get a tremendous amount of utility out of completing this square. I can find the zeros of a function, or I can find the vertex. I can find the maximum or minimum point, depending on how I want to solve the completion. So let's just recap the steps again. I1, make sure that my A coefficient is equal to number 1. 2, I move the C coefficient to the other side, and I like to put little spacers here and here. 3, I take the B coefficient, multiply it times a half, and then square the product. 4, and then I add that to both sides of the equation. 5, I rewrite the left side of the equation as a perfect square. And then, for my 6th step, I have some options. I can either solve it or find the zeros, it's the same thing, depending on how you would like to phrase it. Or I can get into vertex form and find out my maximum or minimum value. It's a really key skill, and it's one I recommend you memorize in advance of the test. Thanks for watching.